Question 11, looking at another distance and velocity problem. You're given the equation for displacement as a matter of time there, function of time. So distance an object is, I'm going to work the displacement after 2 seconds. So 3 by 2 squared, take 24 by 2, take 27, is equal to negative 63 metres. So that means it's 63 metres to the left of your reference point, or a distance of 63 metres, because we talk in magnitudes when we're looking at distance. Now the speed of the particle after 2 seconds. So I need to have a velocity function, which is the derivative of the displacement. So in this case, when x is equal to 2, the x on dt, I like calling it dv over dt, is going to be 12, take 24, which is negative 12 metres per second. So 12 metres per second towards the left, if you like, there, for speed. Now, the average velocity of the object over the first 2 seconds. So what I've got to do there, I've got to find the displacement of the particle over the first 2 seconds. So x of 0 is negative 27 metres, and as we've established, negative 63 metres. So therefore, the velocity average is equal to negative 63 take 27 over 2, which will give us negative 18 metres per second for the average velocity over the first 2 seconds. Before moving on to D, it might help if we get a visual picture of this situation. So this is displacement against time, and you can see where it hits the 0. And it happens at 9 and negative 1. Because we're not interested in motion before things started, we're going to have a positive velocity, and we're going to have a time of about 9. So what I will do, I'll find out the zeros formally. And when I factorise that, that's t plus 1, lots of 2 minus 9 is equal to 0, which is before we studied the motion. So the motion there is 9, and we'll find the velocity at 9. So in this instance, that is equal to 6 times 9, take 24, 54, take 24, which is 30 metres per second. In order to do E, it would be instructional to have a look at the graph. We can see the minimum is at 4, negative 75. So the particle has gone, or the object's gone from 27 metres to 75, which is 48. And then it's travelled an additional 12 metres to get to 63. So total distance is equal to 60 metres. That's the distance it's travelled, not the displacement. Hence, in F, the average speed is equal to 60 over the 6 seconds, or 10 metres per second for the journey we're looking at. So very instructional to have a look at the equation. I've cheated a little bit by locating the minimum at 4, negative 75.